Hey, punks, who's here with us? I see Max in the IM. I see Patrick. But it looks like so far I'm the only one in the video chat section. So if you want to jump in, feel free. I'll get started. Yeah, I'm taping the Stanley Cup right now, especially since it's at least one team I care about. Who hopefully I'll come out at the top of it. But it's good to have you, Julian. Just don't throw scores up into the chat, and we'll be okay. Although I have to say it'll be deadly dull if nobody else joins. At least, you know, with a camera and a mic, kind of kills the conversation. Well, it looks like there's a few people trying to join us. Patrick's popped up.
Hey, how's it going?
Oh, not too bad.
Cool. Yeah,
Take
sorry
it
for the trouble.
your computer hasn't popped up yet.
Sorry?
Yeah, I take it your computer hasn't been fixed.
No, I'm still in the lab to do these. My laptop got bricked, so
Yeah.
yeah. Have you been?
Oh, not too bad. I think I've got my new machine mostly up and running. I think so. We're in reasonably good shape.
Yeah.
Looks like Mark is joining us. Looks like we might have Daniel.
Hey, Mark.
Nice and quiet.
Yeah.
I think you pop in as muted since there's enough of us. Or something like that. We can give it a few minutes and I think we'll have
Okay.
a few more join us. I know Rama and Mike, I think we're certainly going to be here. What was the issue in trying to join? I'm always curious what it looks like on the other side.
Yeah, I don't know. So I was able to access the page of the Hangout, and I was able to play the Hangout passively and see you on camera. But without the link, I couldn't actually join.
Okay. So was it the one I posted that?
Yeah, the one you posted just now is good. So.
Okay. I guess that makes sense. That looks like maybe Daniel joining us.
Howdy.
Hey.
Oh, let me turn this off.
So is everybody mostly keeping up? Kind of, sort of?
Kinda, sorta. It's
Yep.
it's getting tough actually. I just got a bunch of like research projects thrown on me that I'm supposed to be working on, and then I'm teaching a 5-week college algebra course. So it's kind of a little tough.
Is that a big time suck?
Yeah.
It's tough to spend the time you need to get what you need, so hopefully. But I imagine everybody will have some ups and downs throughout the summer.
Yeah.
That'll throw, people for a loop or not, and so hopefully we'll figure out some time to maybe. I kind of meant to put in a week off somewhere in the middle so everybody could play catch up, but I imagine everybody will slip behind and go forward as they have a chance, so we'll see how that works.
How are you finding it? Chapter 3. Or chapter 3.
It's okay, I guess. No colimit and all that fun stuff. I actually only briefly skimmed through most of it, so I'm still kind of a little behind on this. I kind of read through chapter 4 somewhat though. I don't know why. I saw groups, so I was like, hey, I know some group theory. I'll look at that.
Right.
Yeah, that's the way to go.
Yeah.
I kind of can't wait for that part because it's most of the set theory stuff is. To me, I've seen most of it before, although I'm seeing it in a different format here, and he is, I think because the word science is on the cover and not math.
Right.
It seems to me like he's going the non-mathematician route, which I'm sure some of the coders and programmers here will appreciate.
What do you mean non-mathematical?
There's a few places where he's good, I guess, at laying out the definitions, but he doesn't do the typical theorem proof.
Mm-hmm.
A couple of examples here. It's much heavier on examples than almost any math book you're going to pick up.
Right.
But I passed a linear algebra, college calculus text.
Mhm.
But there's a few places where he could throw in some theorems and proofs that he kind of talks his way around them without actually stating them explicitly.
Right.
So I'm not sure. And I'm sure he did it purposefully for the target audience of his book.
Mhm. So, Mark, what have you been making of it?
It's really weird. It's not at all like any of the other category theory books that I've read. So
Right.
far, I'm a little confused about how this material is supposed to be organized. I mean, at least it's pretty clear 3.4 is just other notions in set. So, like, clearly he doesn't think of it as being particularly coherent. I am not sure that I understand the reasoning behind doing everything for sets first and then abstracting it to categories in general, but I'm interested in seeing what people who are not familiar with category think. Is it useful to first give all these examples in the context of sets and then generalize away from that, versus trying to learn them in the abstract in the first place, which is how I'm used to thinking of it.
Mhm.
I'm mostly interested in like observing y'all talk about it, I guess, and seeing what you think.
Mhm. Yeah, I noticed the same thing, right? That things are defined exclusively in terms of the category set, and not like, you know, through universal constructions defining things up to unique isomorphism, etc. Um, it seems like a natural, I don't mind it, but I don't mind the introduction that way. But the general constructions don't come until like chapter 6, I think, which seems like a long time to wait. But I'm curious to know what other people think about that.
Well, I mean, the general construction's like the last chapter, right? I mean, those are like the very end of the book, and it's not even a whole lot on there, I don't think.
Right.
And maybe chapter 5 is kind of long, I don't know. But yeah, since I actually haven't done a whole lot of category theory, so when I'm looking at this, I just see it as just stuff with sets that I already know about. So it's not really, um, I guess, helpful at the moment.
Right.
Because it's just kind of like some set theory stuff.
It
So
doesn't.
I don't know. I mean, if you don't know set theory, I imagine that this might be a useful construction just because, again, I mean, you don't have any of this background, then you have no idea what's going on in the first place. So maybe it's better to, go gradually.
Mhm.
I'm back, by the way. Oh, dear God, Stephen.
You like that?
I should have known better than to accept that. But yeah, here we are. So, I think since I'm the host and every now and then I've got some bandwidth problems here on my end that's been going on and off all day today. As long as I'm here once every 5 minutes, it'll continue on without me.
Okay.
But if I lose connection for more than 5 minutes, it may cancel us out, in which case then I'll try and restart and everybody will have to jump back in, but hopefully I can keep things up and running. So
I'm really behind on the reading.
How far behind? Like page 1 behind?
Yeah, chapter 2. But I did want to comment about the idea that you might want to look at set theory and then abstract out to category theory, which someone asked earlier. I think it's absolutely essential when you're learning these abstract concepts to see specific examples, perhaps 2 or 3, and then, at least for me, then you work it out for yourself, the abstract concept. Because we're pattern recognition systems, that's the way I see it, and I find it less than helpful when I'm reading a book that tells me only about the abstract definition that someone found through examples one time. That's the only way that they discovered this general concept, and then I find it really unhelpful in a tutorial to be told the abstract all the abstract definitions. That's fine for a mathematical definition, like a paper or something, but it's not fine for a book that's supposed to be teaching you about the concept. At least that's in my view. I have chatted to a few people that are trying to learn these things, and one guy said to me that he thinks abstractly or something. I don't get it because I don't. I need examples and then I generalize from that. So it might depend on your learning mode.
Yeah. Well, I think one of the things, and it will depend mostly on everyone's background, how much math they've had, and we've got a pretty diverse group here. It's maybe a third of people come out of the pure math or are working on pure math. There's a bunch of engineers and scientists, a handful of computer scientists. But I find the more time you spend in the pure math side, after you've beaten your head up against the wall for weeks and weeks, you eventually see it often enough, and usually it's in the first preface or the foreword of a book. People will throw around the phrase mathematical maturity. And essentially it means when you're reading a more math-oriented text that this book probably reads a little faster than most because he's got more examples than an upper level undergraduate math book or a graduate math text. But typically you read, if you're reading a Springer text and going faster than a page an hour, you're reading too fast. But they presume you've got a pencil and paper out and you're coming up with your own examples on the side. The nice part about this book is he throws up, I think, enough examples after he gives a definition. Throw around the phrase mathematical maturity. And essentially it means we gotta mute Max. In the text that I think that's where our feedback is coming from. Probably reads a little faster than most because he's got more examples than Max. You with us?
I think I got it.
Okay. But in this book, there's a handful of his examples. I think there was, when he first defines the pullback, within a few pages of the first pullback example, he does a few kind of common mathematical tricks where he looks at a few kind of sub-cases. I think he had one where there's an X and a Y here mapping onto Z, and then there's the pullback up here. And he asked the question, what happens if X is, a single a singleton set, and I think he asks, what happens when one of them is the null set? What happens to the pullback? So small little examples like that are things that once you've been in math for a while, you just know that's a trick to pull off. Whereas in this book, he throws it. He doesn't mention that he's doing it really, but throws those two examples in and works them out to help people kind of through it. The tough thing I think I find myself, and I'm trying to read it more linearly and not skip around, but he does spend, and has a few places, especially in chapter 3, where he says, take a look at this example in chapter 6, which I think is really really where the heavy fun stuff is going to start happening. But I think for those who don't have a heavy math background, some of the stuff in chapter 3, especially in sections like 2, 3, and 4, get very abstract, or almost too abstract, even though the stuff he's talking about really is almost the simple and most basic thing out there. But I find most of chapter 3 for me is he's setting up a whole bunch of individual definitions, and then he's got examples of what those definitions are and what they mean. And we won't actually get into any fun stuff until chapter 5 and chapter 6, I think, when he kind of puts those things to use. So some of the... I don't know if anybody else has a lot of experience in set theory. I've skimmed through a few things here and there and used chunks of it in topology and algebra and other kind of more applied places. But I don't think I've seen this particular kind of setup for basic set theory in a textbook before. I think the closest I've come probably is Munkris does a pretty good crash course set theory bit at the beginning of his standard topology textbook. So if people are stuck with some of the set theoretic stuff, but I don't think he covers things like, pullbacks or some of the kind of more, I'm guessing more category theory specific definitions that he's throwing out. Has anybody else got experience in set theory?
Not that. I mean, I know set theory enough to get through like real analysis and stuff, but not enough to. Like, I never actually took a formal course in it, so I'm probably not a very good person to ask.
Yeah. I've not. I've played with it more, and I probably somewhere I may have taken a set theory course. Although it was probably more like large cardinals and transfinite numbers related rather than day-to-day stuff.
Right.
I see Patrick nodding a lot. Yes.
Yeah, I mean, so there's like the sort of naive set theory that you need to get through like a baby proofs course or real analysis, and there's like Kernig's lemma and large cardinals and all that stuff. And so, which of the two do you have in mind?
Oh no, it's more. I've only had more of the the basics, but I don't think I've not seen a set theory course that uses the word pullback. So to me, that portion is new, but things like, all the stuff on equivalence classes, I think that's another good example. Is there was a section, I think it's 3.3 in equivalence, because I read it a few weeks ago. Mm-hmm. But he's got a section on equivalence classes and partitions and the equivalence between the two. And that's one of the spots where that typically, in any other math text, somebody would have had a theorem proof follow-on to show that equivalence classes are exactly the same, or equivalent to partitioning a bunch of sets and why and how. And I think the nice part is he skips that and just gives you a few sentences and says, he kind of clears out the forest and says, here's a few trees, this is what's going on. And I kind of highlighted 2 or 3 things. I'll try and scribble them out and add them as a post somewhere, as some kind of generic notes if people have missed. But he throws out a few bon mots along the way, saying kind of here's where we're going and what's happening, but he's not making it abundantly clear unless you're reading very closely. So I always find it nice to take those little 1 or 2 sentence statements of here's where we're going and kind of why, but I don't think he hasn't built up enough background to the end of chapter 3 to really do much or say much. So it seems like heavy slogging, and but I've still every other day there's somebody else who's just found out about our group and is ready to jump in and join. And I've been kind of hoping that over the span of the last month, most of the, I think what hopefully is easy set theory stuff for most, will kind of smooth the blow to jump into the heavier stuff in chapters 4, 5, and 6. But I don't think we're going to really get anywhere until we get to 5 or 6. So, but I'm happy to help. I'm happy to help walk people who feel like they're behind up to speed if they have questions about, what is an equivalence class and how does it work and what's going on. Or trying to help them see the forest for the trees.
Chris, you mentioned a book by Bloomkist, I think, on topology that has...
Yeah, James Munkres, Munkres. It's probably one of the most popular topology texts out there. And he has it's almost written at the level that you might take that class without a whole lot of mathematical background or sophistication. It doesn't require any calculus or even linear algebra, really. It's some just basic. It's almost kind of a review of basic, 7th or 8th grade algebra or pre-algebra here in the U.S., but with some slightly more advanced setup.
Cool.
But he does a pretty good job of running you through kind of the basics of set theory and what sets look like so that you can do the topology quickly. And that link you just put through, that's exactly the...
That's the one?
That's the one. I think I want to say it's an international edition. And I think it's in 2nd edition now let me see.
That's the one I have.
Looks like this. I don't think the hardback is in purple, but and somewhere towards the back, I think he has it quits being topology and becomes algebraic topology. But based on what I see, 80% of people taking topology seem to be using that book. Unless you've got Gamelin at UCLA, in which case he's using his own book. So, but does anybody have any broad general questions about what's going on or what we're seeing up and through chapter 3? And then we can, maybe dig in and get our hands dirty on a particular problem or something somewhere. If somebody's got general questions, or if you're behind in kind of a quick overview of what's going on, because to me, sitting down with a pencil and paper and drawing out some of these diagrams and filling in some of the details of the sketches of the solutions he's offering, to me that's where the rubber meets the road, and how to get familiar with some of these definitions that he's throwing out. Come on, Max. I know you got a question. No. These always look weird after the fact when a handful of us are laughing at things in the instant message that no one else can see after the fact. Although sometimes it's probably good that you can't see them after the fact. I don't know.
So here's a general question for folks who are dissatisfied with the organization of Chapter 3. Yep. And I agree that it was a bit loose, right? And I mean, it's certainly not as compact as it could have been. So as you try to compress this information into something that would fit on a napkin, right? How would you do it? So for example, there are a few texts that introduce products, like the notion of a product, and then the notion of a pullback, right? And then somewhere along the way later you get initial and terminal objects. And it's never made quite obvious, or I think Spivak actually does have an exercise about this, that if you know what, for example, what a pullback is, and you know what a terminal object is, then products sort of come along for free, right? So a product becomes just a special case of a pullback when you're pulling back over a terminal object.
All the limits come for free.
Sorry?
All the limits come for free if you have a terminal object and pullbacks. Equalizers too. Every limit you can think of.
Right. I was sort of disappointed that this wasn't made a more focal point in the chapter.
Yeah, it's kind of like he's showing you a whole bunch of individual trees and hiding the forest from your viewpoint. Which from a didactic standpoint has the lovely feeling of that aha moment when you finally get it.
Mm-hmm.
But not having Ren, almost every time he develops something within Chapter 3, especially the second half, he's saying, oh, and we'll see this thing in Chapter 5 or Chapter 6. And to me, that's I think the missing piece is not having the ability to see the more abstract version of what's going on. So it's kind of like, I guess from an analogistic viewpoint, we're learning how to add, and we don't know multiplication is out there to add faster.
Mm-hmm.
But eventually we'll get there and see, oh, multiplication lets you add much faster, or, if you learn exponents, you can even multiply faster, or more simply. And I kind of wish he was showing a little more of the forest instead of just the trees. But I think for those who have no background in set theory, he may be, by forcing you to work through, he may be doing some of us a favor. But I feel like I'm being cheated a little bit right now, so. But it also sounds like Patrick and one or two others have read far enough or have enough experience that they know what's coming around that corner. So maybe if you take a second to explain what that corner looks like.
Chris, do you find it a bit slow then, basically?
The one thing I do like is that there are lots of examples. So I feel like I've got my hand being held way more than most. If we were using Saunders McLean's book, instead of being on, page 115 right now, we'd be on page 3. And I probably would have spent as much time and not know quite as much as I do having plowed through 115 pages to this point, or roughly about there. But I also feel like we wouldn't have. I think there's 6 or 7 of us in the room here right now chatting, but I know there's at least 15 who are relatively actively working on it off on the side, even though they're not necessarily here with us. And I don't think we'd have nearly that number if we were using Saunders' book by itself. So, but I'm curious if Patrick or anybody else is, or those who have scanned ahead to chapter 4 or 5, want to explain what some of these bigger constructs are that we can look back at and make more. Because I think a lot of it will make more sense once we know those from a more abstract point of view.
Well, I think Mark just answered the question I had, which is, what is what's the optimal presentation of these constructions, right? Of products and equalizers and pullbacks, right? And as I said, you just need a terminal object, and then the rest can be defined in terms of those, right? So products is going to be a special case of a pullback. An equalizer is also a special case of a pullback, where the two sets you're pulling back from are the same, right? So I don't actually know whether there's a how much further the rabbit hole goes, but it might, for people who are finding it sort of a slag to get through dozens of pages of examples, trying to compress this onto a napkin, right? But it might be an interesting exercise.
I think it's a great idea to create like a Cliff Notes version of, like a summary really, of the chapters. We could perhaps even use a wiki or something and try and even do that. Chris, you mentioned Saunders McLean. I was just starting that just prior to this group starting up. Maybe on the introduction, I can't remember from the introduction or chapter 1, but it was extraordinarily slow going, and yeah. I think I'm much happier to be tackling this book. For sure.
Well, that's the tough thing too. Is usually the more dry, straightforward books, the graduate level Springer texts are kind of the clarion examples of it, but they expect you to be doing way more work than the author of the text. But even in this, I find myself looking at some of the structural stuff he's laying out in terms of the pullbacks and the push-outs and some of these other things. And I know deep in my heart they're all interrelated, and I want to sit and take my pencil and paper out and plug forward and work it out for myself to figure out how and why. And so I, sometimes find myself doing examples and trying to come up with examples that he, pulls out of his hat 3 pages later that I've spent, an hour and a half, and I've already bulldozed my way past where he's at. Because that's, I've had that experience and I know that's how the math works. So it's nice that my creative side of my brain is working and going in the same direction he is. But at the same time, I'm also kind of enjoying the fact that when I don't have the time, that he's holding my hand down the primrose path kind of as well as he is. I noticed here, too, that Max popped an instant message about the exercise 3.3.2.5, which I have to say is one of the just painful things about the book is He's got about 2 levels too many of decimals in his definitions and examples. Do you know what page that 3325 was on, Max? We can all take a look at it.
86.
Page 86. Okay, I was on 84. So this is suppose that W is the empty set. What can you say about the product of X and Z? Is that the right one, Max? Yes, no? Or is Max still muted out from before?
Yes, it's the right one.
That's the right one? Okay. So was there a particular thing you were having an issue with on that? Because to me, even to me, some of the notation and definitions here really are the tough parts.
I just assumed that there was no intersection, that the two sets are disjoint, and it's trivial. But
Yeah.
you know, am I right? I don't know. I don't really have too much background in math, so that's just my best guess.
So was your question about the definition of what an equivalence relation is? In a sense?
No.
Or the construct of the kind of, co-product of the two, I guess, is the right word.
I'm just wondering what the answer is to the question. I don't know if I got it right or not.
Oh, but even based on what his solution was just below that?
Oh, did he write a solution?
He's got, or maybe it's just the edition that I've got. It has all the solutions written into them.
Oh.
And maybe I'm not here. I'll pull up. Let me see if I'll share my screen and show you what I've got here in the text. And so this is the problem you were talking about here, right? This highlighted one. So I don't know if everybody else has the same version of the text, because the MIT sent me some fun goodies ages ago when I started this whole experience. But my assumption is this is the same version of the text everybody else has that's got these solutions thrown in there.
Chris, I threw in a link to the HTML version of the book, and it doesn't have those solutions there, just the exercises.
Oh, okay. I'll share this one for you, but this is a good example, and it's not too dissimilar from the one I mentioned, and I think it was in section 3.2, where he was talking about pullbacks, and then he looked at 2 specific cases, and it's very similar to the concept for those who have experience in group theory, where you define a group, and then the identity is kind of the smallest self-contained piece of a group, and then the whole group itself are both subgroups of the bigger group. So he's kind of doing that same thing here and looking at the case where, what happens when W is the empty set. So this exercise and then the exercise just before it or below it, the 2.6, are kind of 2 sides of the same coin. One is the empty set is the smallest sub-example one can think about, and then the other, he looks at all of the natural numbers and then uses the one element set to see what's going on between the two. But when W is the empty set, it kind of shakes itself out, and then the equivalence relation that's there is trivial. And I don't know if it's... I haven't looked at how he typeset the stuff in LaTeX, but to me, some of his notation with the cups of W, when I first came across the notation, I think in the beginning of chapter 2, because he did on some of the pullback stuff, he does a X cross Y, and it's X sub Z, I think, in most of those. I always feel like that typesetting between those two letters should be a little closer together, so it's more obvious that that's an operator in the middle. So if that's caught anybody up, it's... I think the typesetting could have been a little clearer in some of them. Here, I guess it's... Or maybe I'm just getting used to it now, too.
So did I pretty much get it correct? They're
so yeah,
disjoint
based on what you said, it sounded like you because you mentioned that the equivalence relation part was trivial, but I think this part here that I've highlighted in the middle, the fact that the W essentially just drops out, and then gives you the co-product. It's kind of odd because there were one or two other people that I talked to a week ago who had bought physical copies of the book, and their physical copies also had all the solutions written in them too. So I don't know if it's maybe it's a U.S. market versus an Australian market distribution issue, Steve. I don't know.
I'm just using the online version of the book, so it could be that that one doesn't have the solutions.
Yeah, that's possible. But so if anybody has a specific question, obviously we can cut and paste and throw those things out so that you've, depending on the edition of the book you've got, you're getting the right answers. But I think most of the ones, typically, he'll throw out an exercise, and I usually ignore the fact that there's a solution and start chugging away. So
What's the solution to 3.3.1.5?
Let me pull my page out here.
Letter A.
Oh, 3.3.
Which page was that on? That may help me find it a little quicker.
77.
So this was 3.3.1.5, you said?
That's right.
Yeah.
So this is basically asking you to find this R of F, or basically any element inside of the set, such that they're not equal, but they satisfy this this f of x equals f of y. So basically the idea is, okay, can we find two numbers that satisfy cosine x equals cosine y, but x is not equal to y? So basically you could probably pick any number, x, and then you can get another number just by adding a multiple of 2 pi to it. So you could, basically this set would be x comma x plus 2 pi k. So because whenever you add 2 pi to your cosine, or to your argument of your cosine, you just get the same thing, right? So I think that's, hopefully that kind of maybe explained it. I think they just give a specific example here. They just said 0.7 and 2 pi plus 0.7.
I probably got it wrong, though. I just kind of figured that, well, I guess I was kind of missing something. That's interesting. 2 pi cosines a little bit above my pay grade. But what if you just simply said that the two legs of the triangle being 1 unit, the hypotenuse being the square root of 2, you simply have a cosine that's not equal to the cosine x equals 1 over the square root of 2, and 1 over the square root of 2 equals y, so x doesn't equal y, but both are real numbers, so it works out. Is that completely off?
Okay, so you said that cosine of x is 1 over square root of 2, and then cosine of y is also 1 over square root of 2, but the x is not equal to the y?
The triangle has 2 legs that are 1 unit long,
Mhm.
and so x is the angle where those 2 legs meet. The hypotenuse is going to be the square root of 2, so then the cosine is going to be 1 over the square root of 2, right? And so here you have x is not equal to y at all. They're not equal. So that part's true. And then you have that they're both real numbers. So you get the real numbers, the r times r relation, the real number times the product. You get the what's called the you get that Cartesian real number times real number relation. If I'm saying that correctly.
So with the triangle with 2 1 unit legs, so both of the angles there in that triangle are 45 degrees, right? And I don't, let me think here. So we might be misinterpreting this a little. So basically the idea is, okay, so we want f of x equals f of y, and our f of x function is the cosine, right? So we want cosine of x to be equal to cosine of y, right? So the idea is that, okay, can we find two arguments, x and y, that are not equal, but the cosines are equal to each other? So can you find two different x's that give you the same 1 over square root of 2? So can you find an x that gives you 1 over square root of 2 and a y that gives you 1 over square root of 2, for instance, that are different angles? And
Okay,
it
well
helps. It helps to generalize the definition of cosine to the unit circle. Here, let me. And there's actually an important property about a cosine, is that it's something called periodic. So every if you keep adding 2 pi to the argument of the cosine, you get back to the same place. So you can think about this as you're going around the unit circle. So the unit circle definition of cosine is basically it's the x value, right? So as you're going along the it's x, right? Right.
Yeah.
So you're going along the unit circle, and as you go along the unit circle, the x value changes, and so every time you go around the unit circle one time, you get back to the same place. But we keep adding the degrees keep going up 360 degrees or 2 pi every time. So whenever you go around once in the unit circle, you end up at the exact same spot in terms of the value of x on the unit circle, but the argument changes, the x changes.
Oh, interesting. Okay.
So
Work that out.
they have like some nice pictures on Wikipedia. I don't know if you've ever looked at this, but some
There you go. I don't know if that helps. Is that what you're looking for? There. But yeah, these are like ubiquitous on Wikipedia. Whatever. Okay. You have an angle theta, and the x value, where that ray meets the unit circle is cosine of x, and the y value is sine of x. That's all.
Yeah, and so this last one that's bad. I put 2 links, but the second one is a picture of cosine, and if you look at it, you can tell that cosine of 0 is the same as cosine of 2 pi, and they're both 1. So 0 and 2 pi would be an element of this R of f. Why? Because cosine of 0 is equal to cosine of 2 pi, but 0 is not equal to 2 pi. Well, it'd be one of them that satisfy that, right?
Yeah, I'll take a look at that.
Yeah, if somehow in your math background you haven't completely memorized the unit circle, sine and cosine, arguments. Spend a half an afternoon and just memorize it.
I still don't have it memorized. I just look it up whenever I need it. I'm kind of lazy.
If I had to do that, I'd be looking it up every third day.
Oh no, yeah, I don't use it that often.
I guess maybe it's my electrical engineering background.
Yeah.
Just use it too often. I think I popped on and popped off a couple of times. And I think they gave kind of his hard answer on that 3315 was a little hand wavy, I think, but certainly makes sense. Or it did to me.
So, which one? Was it C?
I think it was, yeah. To me, I remember learning those back in abstract algebra, the quotient function in x over tilde, that notation is always quirky and tricky, I think.
Yeah.
But once you write it down and scribble it out a handful of times, and I think if people are having problems with parts like this with that notation and what a quotient or quotient function are, I would recommend Thomas Hungerford has an Introduction to Algebra, Abstract Algebra textbook. I think Saunders Publishing put it out ages ago. Get a first or a second edition. The third edition, I think, is almost $300. and it's a nice book, but it's not worth that much, particularly when you can get the second edition for $15 or less. I think he did a pretty good job of explaining that notation, or goes into more detail than Spivak does here in this textbook.
I never used this book, but I always see this one thrown around if you ever into like Intro to Abstract Algebra. It's like a Dover book, so it's like $6.
Which one's that?
It's Pinter.
Ah, Pinter.
Oh, yeah, Pinter's book's pretty good.
I've never actually used this, but I can't tell you about it. I mean, I always see it thrown around, and I guess it's probably good.
I have a favorite abstract algebra introduction. It's Jacobson's book, Basic Algebra.
Yeah.
I think Dover publishes that one too. It's probably not very expensive. I looked at a number of introduction to abstract algebra books, and I think that one is the most accessible.
Okay.
Jacobson.
But
Yeah, I think I've seen
all over
so
the
many
place.
of those.
You gotta get our set theory book, or topology book, or group theory book, just so we can go through Spivak's category.
My queue is getting longer.
Yeah. When I first saw this book, I thought it was a different Spivak. I always see for like calculus on manifolds and differential geometry, and that's a Michael's, and this one's David.
Yeah.
They're apparently both pretty respectable people, though. So
Yeah.
it just confused the hell out of me. I don't know.
That was my first thought, too, when I heard Spivak as a last name. My first thought was literally publish or perish, which is Michael Spivak's publishing self-created publishing company.
So for the people who worry that they might have to repair to an introductory abstract algebra or topology text in order to feel like they're getting something out of this, that sounds like a lot to put on one's plate all at one time. So would people find it useful if we if some of us here who are feeling more comfortable with it committed to like office hours outside of, or have people been using office hours and getting something out of that already? Because it sounds like a lot to do on one's own, right? To read 2 books at once, one being a prerequisite for the other.
Yeah, no, that's a really good point.
And I don't think this book was made to have prerequisites, really, right? But I think that's kind of his idea of introducing the set first and everything. But I imagine it'd probably be a lot easier if you knew the background, right?
Mm-hmm.
How many people here have at least some of that, I got the impression that at least 4 or 5 people had some abstract algebra and some set theory and 1 or 2 other things. I imagine Max probably didn't have as much. And Steve had sounded more like a hardcore computer scientist rather than a mathematician or an engineer.
Minuscule.
Yeah, I don't know any of this stuff. I thought I knew set theory because I did some of that at school, and you mentioned a few things before that I probably haven't heard of. I think equivalence classes comes up in type theory, and I've read a little bit of that stuff. And in functional programming, a lot of these things like monoids come up. So they're familiar to me.
Be right back.
I was curious about these things coming up. I think in chapter 4, monoids and things like that, groups. Is that strictly category theory? I thought that was abstract algebra.
Yeah, you'll typically encounter them first in an abstract algebra course, but I guess the idea is to give a categorical interpretation of a monoid or of a group.
Well, the point is that monoids and groups, which are a special case of monoids, are particular cases of categories.
Sure.
And that's one perspective on them. You can think of them as algebraic structures, and that's the abstract algebra perspective. you can also think of them as a special case of categories, and then you get to restrict all the theorems you prove about categories in general to monoids and groupoids and partial orders and sets and all kinds of other stuff, because all of those things are special cases of the category axioms.
Right.
And of course, then there's also a category of groups, and that might be enlightening depending on what you're trying to do. And of monoids. But on the other hand, right, if there's some context that you're familiar with that makes a certain definition come to life, it's probably something that many of the rest of us are missing. So, please bring it up to share with the rest of the class.
I think one of the things that may help Stephen out too, if he's not got some of the set theory background, when you're looking at things like equivalence classes, probably the simplest example, and I don't think he mentions it, is, and even with computer science background, you'll have played with, modular numbers or, basic clock arithmetic. So when you look at a clock and you get to 12 o'clock and then an hour later you circle back around to 1 o'clock, those are typically the kind of most basic example of what either an equivalence class or a partition looks like. So you can partition the clock up into 12 hours, and then as you go through, you'll start at 1 o'clock and then cycle back around, and then at 13 o'clock you're in the 1 o'clock's bin. So 1 o'clock and 13 o'clock are equivalent and in the same equivalence class, and 1 o'clock can stand for both itself as well as 1300 hours. But having some of those kind of basic examples while you're working through some of these may be helpful. I actually was kind of surprised he didn't throw that out as a standard example when he did it. So what else are you thinking, Max?
I have a ton of questions. I mean, some of the exercises I was able to solve, some of them I wasn't able to solve, but, of course, I could just try to find the solutions online to a good deal of them. I don't want to hog up too much space with stuff I could take care of on my own to a degree.
Well, are there any bigger conceptualization pieces?
Well, conceptually, I kind of get the idea, but conceptions don't mean anything when you can't solve the exercises.
Yeah. Well, I'll dig up my copy and I'll email it to you so you have at least an idea what that part of it looks like.
Okay, thanks.
And that may help or at least fill in some of the things so that you've got an idea of what's going on. Is that Max Jr.?
He really wanted to say hi. I don't know why.
Hey, mathematicians in this group keep getting younger and younger every week. So, in fact, I think we had somebody join us, I think, from Caltech this week, although I didn't see him in the chat. But I'm expecting him to be 12 or 13 maybe. Or her.
Oh, nice.
So, we'll see what happens. Well, we're just past the hour mark. And I'm happy to stay as long, or if people want to catch me. I've got a block of a couple hours on Friday morning that I'm usually around if anybody has questions or I'm online about half the day, I think.
You're in Los Angeles, that's right?
Yeah.
Yeah. Yeah. Okay.
Does
So I'm happy
does
to
that go
defer.
past noon?
What was that?
Does that go past noon?
Um, usually on usually most Fridays I'm kind of stuck around noon because I have a standing lunch. Um, but even then, I'm usually around later in the afternoon, so I try to be logged into Google Plus or on Hangouts for big chunks of the week. So if you have questions, I'm around a good bit of the time. And if I remember, I think probably about half of us, I think, are in Los Angeles or on the west coast of the U.S. There's a couple people on the border of the central time zone in Michigan. There were probably 7 or 8 people, I think, on the East Coast, 2 in Australia, a couple in India. There were 4 or 5 people, I think, in Central Europe who I'm sure were missing horribly because of time zone differences. But if it's useful to people too, we can always, put together a session or two outside of our usual standing Monday. Just post a note up on the blog or send me or somebody else an email, and we'll see if we can arrange something. That way we don't. I mean, my goal is that we're going to start losing people in the next 3 or 4 weeks because we're going to get into the heavier weeds. So and somewhere in the middle of the summer, if we need to, we can take a week off so everybody can play a little bit of catch up, because it is a relatively ambitious pace for a group of people who are doing 15 other things. So I don't mind, pushing it out a few weeks. Sooner or later, I'll finish it all myself, But if it helps to keep a core group of 8 to 15 people together, I'm happy to bump a week or two, which many of us have done in the past anyway. I think guys like Rama and Mike and Dave Sneed have, spent months and months on topics like Lie groups or, quantum gravity or whatever, and somebody's not available and you can't keep a quorum, you just push off to the next week. So, but ideally, I'd like to try and keep some kind of schedule or close to a schedule as we can.
Right.
So, I'll email Max a copy of what I've got so that you're on the same page. If anybody else wants it, send me a quick instant message and I'll cover you. And I've also got some additional examples and solutions. If people have the time and inclination to plug through them.
Great.
So, anybody else got any questions? Am I missing anything along the way here? I don't see anything else in the chat that requires answers, so. All right. Speak now or forever hold your peace.
I'm good.
All
See
right.
you guys next time.
We'll call it a week, and I think next week the first 2 sections of Chapter 4. So we'll see everybody at the same bat time, same bat channel.
Right, have a good weekend.
Hey, great.
Ciao.
Night, guys.
Thanks very much.
And email during the week if you have questions. We're here 24/7, I guess.
All right.
Great.
Take care.
See you guys next
Cheers.
week. Bye.
Ciao.